Hi everybody, welcome to Test 1 review for Calculus 1. On the top you will see the topics that we'll go over, and when we finish the topic I will draw a line through it and then we'll move on to the next one. I'm sorry for a bit of a delay. By the time this video is being uploaded and processed, it is Saturday morning already. Right, so let's start. So first, we'll find the limit for given graphs. So we'll be given the graphs like this, and then we ask to find the limit. Right. So the first one, the limit of the function when x goes to -1, did not specify from the left or from the right. So we have to consider both. First, x goes to -1. This is -1, and from the left, the function go to that point, and on the right, the function when x approaching to this vertical line, y values approaching to this point. So whatever this point is, that will be the limit, and that is at 3. So we say that equal to 3. Oh wait, sorry, is this 1? Right, if this is 1, then that will be 3/4. Yeah, depend on the scale of things. So yeah, so 3/4, because 1 is right there. Sorry, didn't see that. Right. Next we have one-sided limit. This limit go to when x go to -1 from the left, superscript minus, and go from -1 from the right. That is superscript plus. So on the left of -1, this is -1, and on the left of it, the function goes to this point. So we write a limit of the function where x goes to -1 from the left is equal to the y values of that point, which is -2. And then the limit when x goes to -1 on the right, it will approach to this point. So we say limit of the function as x goes to -1 from the right is equal to -7. Right, so that from the left and that from the right, and we see that these values are not the same. So although the question did not ask us to find it, but we'll say the limit where x goes to -1 without the plus or the minus, meaning it goes from both sides because they're not the same. The limit of the function when x goes to -1 does not exist. So that is how we find the limit based on a given graph. Could be one-sided limit, or could be just a limit on both sides. Right. Next, we'll find limits using a table. This we'll use the calculator. Right, calculator. Right. So let's look at this problem number 3. Yeah, so we can put it like that. Right. Now we just need to evaluate the function when x go to 4. So if we put 4 directly in here, we will have something divided by, 0 over 0. Divided by 0 is undefined already. So what we do is we just evaluate the function at these values of x. So first I will enter the function. Right. Hit y equal to, we have x minus 4 divided by x squared minus 5x plus 4, and then we will find the values. So if we hit the second trace the values around the first one, it will give us a graph and we say when x equal to 3.9, we have 0.3448. And then we have 3.99. And we do not need to hit the second trace every time. Once we have at this stage, we just hit the end, just enter the values for x, and we have the values for y. So we plot the function and find the values of the function at this values of x. Those are the y values. Although when we, by the way, just confirm that if we hit 4, y will be undefined. So that's why we don't have any y values here when x equal to 4. So that we're not going to be able to get the limit by just evaluate it. We see the pattern of x, the pattern of y at x go to 4 in the middle. On both sides, the y values go to like 0.3333, I would say. Which is about 1 over 3. Right, so that is the limit using the table. Next we have a limit for a given function. So the function might be something like this. Right, first find the limit. We look at 5, 6, and 7 here. Right. So the first thing when we try to find the limit is just put in the numbers in for x. We have 0 cubed minus 6 times 0 plus 8 and 0 minus 2. So we have 8 on the top, negative 2 at the bottom, and that is negative 4. Notice that we did not write the equal sign from the beginning. We just put in the number in for x, and that's what we have. Now, because negative 4 is something that is defined, so we set the limit equal to that. Right. So the first thing when we find the limit is just put in the values. If it is something nice and even like this, we know the answer is negative 4, straightforward. Right. 6. I put 6 in for x. So I have 36, 24, 60 minus 60, that will be 0. And we have 6 minus 6. So that will be 36, 24, that's 60, so will be 0 over 0. Again, we do not write the equal sign yet, because this is indeterminate. It is indeterminate, so we cannot set the limit equal to that. What we do, however, because both of them equal to 0 when x equal to 6, we know that x minus 6 is the common factor. So we're going to have the x minus 6 and then something else. Now that's something else. We need to have x squared, so we need an x here, and we need to have negative 60, so a plus 10 here will do. Right. Now that cancels out. And we have that. Now just need to put in the number. Again, I will not write the equal sign yet. And if it is anything nice and even, we will make the limit equal to that. So if we have 0 over 0 at some certain values of x, then x minus that number is a common factor. Right. It is indeterminate, and the solution to that is, of course, try to factor. Number 7, we try the same thing, put in 4. And we have 0 over 0. Right. It can be shown that later on we will have x minus 4 as a common factor. But for now, we have indeterminate. So in that case, we'll multiply by the conjugate of the term that has square root. So here we multiply square root of x plus 2 now we multiply it out. Square root of x times square root of x, that is square root of x square, and later on the square will cancel the square root, right? Plus 2 square root of x minus 2 square root of x, and minus 4 all over x minus 4 and square root of x plus 2. We could multiply this out as well, but since we have 0 when x equal to 4, it's better to keep the x minus 4 there. Right. Not only that cancel, the middle terms also cancel nicely. So we just have x minus 4. And then at the bottom we just have that. So we can cancel out x minus 4. And we have that. Because if we put 4 in for x, and it is a nice and even number, I mean not infinity, we'll make it equal to. Right. So when we have 0 over 0, more than likely we have a common factor. And they will cancel out, and the rest of the problem should be simple. Right. One-sided limit. I'll take a look at this one. Right. Second, if we need to evaluate secant, we have to rewrite secant as 1 over cosine of x. Now if we put negative pi over 2 into it, we have 1 and negative pi over 2. If we use the calculator, make sure it is in the right mode. Right, it's radian. So we have cosine of negative pi divided by 2, and we have 0. So we're going to divide by 0. That's not good. Usually when we have that, we need to know that what happened when x go to negative pi over 2. The question is asks us to find the limit from the left only. So what we do is we say negative pi over 2 and if we want the number from the left of it, we subtract a very small number. That will do. Yeah. So we have negative pi over 2 and then subtract a small amount. So that's what we have. Now we have cosine of that number is negative. So this is negative and end up being negative infinity. Right. Sorry, the calculator is on the way. So it should be that. By the way, when we put in the numbers, we take negative pi over 2, subtract a small amount. We're going to have the number on the left of it. And then we just substitute and find the math. Positive divided by negative is negative. So that is consistent. Next we have the limit at infinity. By the way, this is a sample of the infinite limit where the limits equal to infinity or negative infinity. A limit at infinity when x goes to infinity or negative infinity. What we have is this. As x goes to positive or negative infinity, only the highest power terms matter. Alright. So like the first one, when we look at this, we'll see that we can rewrite that as x to the negative 1/2. What we see is that when x goes to infinity, the one with the high power matters. The negative one here doesn't do anything to contribute to the limit. So the limit when x goes to infinity, the x to negative 1 here is not significant. On the top we have negative 3x to the 1/2, and the bottom with the high power we have the negative 5x instead of 4. Right? Now find the limit. Put in infinity doesn't help because infinity over infinity is also indeterminate. What we do instead, negative 3, negative 5 is going to be 3/5. And then when we divide two things, we subtract the exponent. So 1/2 minus 1. So we have 3/5. Sorry. Limit x to infinity of 3/5 x to the negative 1/2. Of course, this negative 1/2 we can move down to the bottom. And now if we put infinity in it, that is positive, and that is 3. So have 3 divided by infinity, so going to be 0. Right. So the first one in the infinite limit is this. When x goes to infinity or negative infinity, only the one with the highest power term matters. Right. Now, so what we have here is a finite number divided by something that goes to plus or minus infinity will be equal to 0. Right. Next one, we have a properties. Square root of a squared is absolute values of a, which is itself if it is greater than equal to 0, and it is opposite to it if it is less than 0. Right. So the first thing we do is exactly like that. We take the one with the highest power. Meaning just this. The bottom I will take the highest power of those two will be t. Right. We can split the square root. And square root of t squared is absolute values of t over t. Now we're using these properties. It will be itself if it is greater than or equal to 0. Since t goes to infinity, t is positive, and when t is positive, it will be equal to itself. So just t. So it's going to be just 5t. So the limit of that function is, we have 5t over t, and the t cancel, so that is equal to 5. Right. So when we have the square root, and then inside that is square and something else, take the highest power only. But that only works if x goes to infinity or negative infinity. If we don't have that, we cannot do it this way. So the rest of the problem is pretty simple. We take the highest power on the top, the highest power at the bottom, and then try to simplify. Right. I'll take a look at 14. So if we take the highest power on the top, it will be 4x cubed. And at the bottom, the highest power is not the x, but it is negative 5x squared. Right. Now we simplify negative infinity. 4 over negative 5, not much to it. Now the power. Dividing is subtracting the powers. That gives us negative 4 over 5 x to the first. Right. Now if we put negative infinity into it, it will end up being positive, because negative times negative is positive. We'll say infinity, because infinity divided by 5 is still infinity. Right. So when x goes to infinity or negative infinity, the highest power term matters, and we have a finite divided by infinity is 0. Here we have infinity divided by a finite number, so that will be infinity. Right. So I have 11, 12, 14. Vertical asymptote and horizontal asymptote. Now to compare the result from these two pages, this we have the limit equal to infinity, therefore we call this is infinite limit. This is where the function go to infinity or negative infinity, and the values whatever we have is a constant and not infinity. essentially we might have infinity when x go to infinity, y go to infinity as well. But when x go to infinity or negative infinity, that is the limit at infinity. And here's a few things that important. Right. Here we have infinity divided by a finite number. In this case 5. It's going to be plus or minus infinity. And infinity over infinity, that is indeterminate. So we have those scenarios. Right. Vertical asymptotes and horizontal asymptote. Vertical asymptote, for this function, the function has to be discontinuous for it to have the vertical asymptote. So for this function to be not continuous, meaning that it is undefined when the bottom equal to 0. So we write if the bottom equal to 0, so we have x equal to -4. Right. So first we find the function where it's undefined, because the vertical asymptote occur when the function is undefined. If the function is undefined, potentially we have the vertical asymptote exists. We still need one thing though. Need to make sure that the limit goes to infinity, either from the left or from the right. Here I just take x go to 1, 4, actually -4 from the negative sign of 3x over x plus 4. So we're going to put -4 into it. So the top is -12. The bottom that will be 0. So we have -12 over 0. Now, just need to determine if it is a positive or the negative side of 0. So I have a calculator here. Right. We have -4 on the left. Sorry, turn it on. -4, and we subtract a small number. So it will be on the left side of -4. And let's store that into x. Now we just need to say x plus 4. It is easier to do it like this rather than try to reason from there. So we're going to have the negative number. Negative divided by negative is positive. So yes, indeed the limit goes to infinity. And that's where the function, is undefined at x equal to -4. So we have those two things. The function is undefined, and then the limit from one side it must exist equal to positive or negative infinity. First we find the gap for, so that is where the vertical asymptote could exist. After that we confirm that the limit from one side, either the left, the right, or from both sides, if the limit is not equal to if it's not infinity, then we do not have the vertical asymptote. It has to be infinity. Right. Now this, the function x goes to a constant, the function go to infinity. For horizontal asymptote, it will be completely different. So all we need to do is just find the limit when x goes to infinity of the function, or where x goes to negative infinity of for the function. Right, I do just one for the infinity here. F of x. Again, since x goes to infinity, I will take the highest power, x squared, and negative x to the fourth at the bottom. Now simplifying, we'll have x go to infinity. It's negative 1 over x squared, because we cancel 2 of x squared, and we have that. Now, since x goes to infinity, we have negative 1. The bottom is infinity squared. So, a negative divided by a positive is going to be negative. And that a finite number divided by infinity, so that equal to negative infinity. Sorry, I just say finite over infinity is 0, so that is equal to 0. So we have y equal to 0 is a vertical asymptote, I mean horizontal in this case. So we just find the limit when x go to infinity, and that limit equal to 0. Therefore, y equal to 0 is the horizontal asymptote. To find the horizontal asymptote, it is a lot easier. We just find the limit when x go to infinity or negative infinity. By the way, I leave that one to you. So we have just 15 and 10. Right. So horizontal asymptote, just find the limit when x go to infinity or negative infinity. Vertical asymptote, the function must be undefined, so there's a gap, and then potentially the vertical asymptote. But the limit when x go to whatever the numbers for the horizontal asymptote, it has to be infinity or negative infinity. Right. Find the values so the function is continuous. So there are a lot of factors involving continuous, but let's go over that again. The limit exists, the function is defined, and they're equal. But let's just look at the limit. If we have the limit when x go to 6, let's do from the left side, meaning less than 6, and we use this function. Right? And when we put 6 in it, it is just 36. Right. One thing though, x squared, it is a polynomial, it is continuous everywhere, and so it's good for x less than 6. X plus k is also continuous everywhere, so it works for x greater than 6. For the piecewise function, we only need to check the gap between the two functions. In this case, will be 6. We need the limit when x equal to 6 must exist. Right. Now we check the limit when x equal to 6 but from the right side. In that case, we have to use this function, because that is when x equal to 6 from the right, x is bigger than 6. So we will take this second part of the function. So we just have x plus k, k, and we're going to put 6 in for it. So limit on the left is 36. Limit from the right, 6 plus k. In order for the function to be continuous, at least the limit must exist. So we say 36 equal to 6 plus k, and we solve for k equal to 30. So it will be just like this. Of course, we can check the function is defined and they are indeed equal, but just at least the limit from the left and limit from the right must be the same point. Right. Next, intermediate value theorem problem. This will be easy. We're going to put 4 and 5 into the function and see what happened. And I'm going to use a calculator on this one. Right. Since we only test 2 values, I don't need to store. But if we want to, we can always do that. Do x cubed, that for x cubed, minus 7x squared, minus 9x, plus 4, plus 4. Alright. I thought I entered 7x squared. Right. Insert an x into it. 2x cubed minus 7x squared minus 9x plus 4. Right. Now we graph it. And then second trace. Let's find the values. When x equal to 4, hit 4, and we have negative 16. And we're going to put 5 in it, and we have 34. Right. Intermediate value theorem. If we draw a little sketch from 4 to 5, when x equal to 4, it is negative 16. And when x equal to 5, the function equal to 34. Now, if the function have to go from this point to that point, it has to cross the line in between 4 and 5. So in that case, it shows that there has to be a 0 between 4 and 5, because this function is continuous. Go from here to there, it guarantees to cross the 4 and 5 somewhere in the middle. We cannot go around it because it will not be a function. Right. Right. We go to every brave change first, and we'll get back to prove the limit using delta and epsilon. Right. So average rate of change f of b minus f of a over b minus a. Right. In this case, we have from 2 to 8, so we have f of 8 minus f of 2 over 8 minus 2. And we're going to put 8 in it and then put 2 in it. So the function at 8 minus the function at 2. So that is square of 16, which is 4, square of 4, which is 2, over 6. 2 over 6 is 1/3. So we just that. So every rate of change is this formula. Every rate of change of the function when x go to one number to another. So in this case, it doesn't matter which one is a, which one is b. We just go from one point to another of the function. Right. Next. Next, we prove limits using the epsilon and delta. Right. So for this, the proof, if we write just the proof, it's kind of backward. And so we will do this. It is more natural in this direction. So we need to start use red. We start at the distance from the function to L less than epsilon, and at the end we will have x minus a less than delta. From there we can say delta is equal to something. Right. The proof itself is just one part, but like I said, it's difficult to write in that direction. So we're just going to have to do that forward and then backward. Right. Now, first, we do need to know the definition of limits. So, of course, that's one part of the question. But we're going to have limit when x goes to a number of a function equal to L. So with that in mind, we will have the function is 3x minus 2. L, the limit is 13, and the values of when x approaching 2 is 5. Now, we start from the limit of, the function minus the limit must be less than epsilon. If we have the graph, first we limit the y values. So the values of the function have to be within some interval of L. So the function minus the limit less than epsilon. Now we just put in 3x minus 2 minus L is 13. Absolute values less than epsilon. We have to have absolute values because we might have a point that is bigger than L or a point less than L. So throw in absolute values guaranteed it to be positive. Right. Now just do the math here. 3x minus 15. We can factor out the 3. Now we can have the 3 outside. I'll just need one little thing though. Because absolute values guarantee it to be positive. So if we write the 3 outside, the 3 is positive. So that is alright. If we have negative 3 here, we cannot write negative 3 outside. Remember, this has to be positive. Right. And then if we divide by 3, we have x minus 5 less than epsilon over 3. And that's what we match with this, which is x minus 5 less than delta. Well, we let delta because now we can match those two, and we say delta is equal to epsilon over 3. Right. So we start with that and work the way out until you have x minus a less than delta. In that case, epsilon function of epsilon will be equal to delta. Right. Now the proof. The proof we write backward. For every epsilon positive, we can choose delta equal to epsilon over 3. Now all we do is just write this backward. So we start from here. X minus 5 less than epsilon over 3, which is delta by the way, and then multiply the 3 over, take the 3 inside, multiply it out, and then we can write 3x minus 2 minus 13 less than epsilon. So, like I said, usually from this to this, it is more natural way to go from 3x minus 15 back to that. But we do have the limit, the absolute values of the function and the limit less than epsilon, which is exactly what we need. So in that case, we say the limit of 3x minus 2 when x equal to 5 is equal to 13. Alright. So to prove, we just write this in reverse. And when we have that final statement, we say repeat the limit statement, something that we just proved. So that is proving something using delta and epsilon. Limit statement. Usually it's just a linear function, something small and easy, not something complicated. We just did this too, so that will be 22. Next we have derivative using the definition. So we will look exactly like this. The formula for derivative using definition is given. Just need to apply that and find the limit. Find the derivative of this function. Right. By the way, If you look at the review for the breakout, it's kind of the same thing as this. Right. So that is the definition of the limit. So we have this minus the function itself. So let me write out again. Limit when h go to 0 of f of x plus h minus f of x over h. So put the box around f of x plus h. So we start with a function in general. We have the negative plus 4. So pretty much what I did was I replaced an x, just a pair of parentheses. If we put x plus h in it, we have to do that for every part of it. Right, now we multiply it out. For x and for h. Multiply it out, negative x squared hx and h squared. Of course, I still have the parentheses when I multiply it out for x, for h. Right, now remove the parentheses. We have negative x squared hx make it 2, but with the minus as well, and minus h squared for x, for h. So that is the red part. The function itself is just negative x squared plus 4x. Right. First, we're going to have the part in red, which is this, minus that. So we start with negative x squared, negative 2hx. Sorry, I write a little bit small here. For x, for h. Pretty much that. I'll put in the square bracket. Minus the original function of negative x squared plus 4x. Right. Remove the parentheses and simplify. So negative x squared, negative 2hx, negative h squared plus 4x plus 4h minus the negative is a plus, minus plus, minus. Right. A common theme here when we do the different quotient with the limit, if it doesn't have an h, it should cancel. This one has no h, should cancel with something. So we have negative 2hx, negative h squared plus 4h over h. So we cancel anything that doesn't have an h in it. Now all of them have h. We can factor out. Just an h. Negative 2x, negative h plus 4 over h. We can cancel. And we have just negative 2x, negative h plus 4. Now when h equal to 0, put 0 in for h, and we have negative 2x plus 4. Of course, this one, the question, this specifically asks us to use the definition. Otherwise, if we use the power rule, we can go directly negative 2x plus 4, straightforward. On the test, you need to demonstrate that we can use the definition of derivative to find the derivative. Next one, we have the square root of x. We write first the definition. Right, so the one red and the original function. Right. So in this case, the function in red is rather simple. We just have x plus h into x. Minus, that is the original function, over h. Right. Now, of course, we can put in 0, but usually it's not going to be simple because we're going to cancel the h later. Usually, if we put 0, divided by 0 is undefined, so that's why we don't put the numbers in. What we do instead is trying to simplify this. And if we go back to number 7, when you're trying to find the limit with that has the square root in it and undeterminate or something like that, we will multiply by the conjugate of the one with the square root. So we say 2 x plus h minus 2 square root of x over the same thing. Right. Now we'll multiply it out. Right. Those two because they are the same, so I will make a square. And these two so the conjugate, so must, this one is the minus, this has to be a plus. So that and that plus, that the minus, and then minus again. Right. The reason we use the conjugate because the middle term just cancel out, and we just have 2 squares, 4 square root and square. that cancel, and we just have that. So we have 4, and now we have just that. And then we put 0 in for h. So we will have 4 2 square root of x plus 2 square root of x, which is 4 over 4 square root of x. The 4 cancel, you have 1 over square root of x. Right. So when we're trying to find the limit that has the square root, more than likely we multiply by the conjugate. If it is indeterminate, definitely we multiply by the conjugate. And then this one too. The function here, that is when x plus h substitute into x, so we have 7 over x plus h minus f of x, that is the original function, over h. Now we're trying to simplify this. We simplify this by multiplying by the least common denominator of x and x plus h. Right. So pretty much we multiply that to everything. And bottom we still have hx and x plus h. Again, don't multiply it out. We need this h to cancel later. Right. Talking about cancel. The x plus h cancel here. X cancel there. So we will have limit when h go to 0. We just have 7x minus 7 x plus h over x and x plus h. So I multiply it out, 7x minus 7x minus 7h over hx x plus h. Again, like all of those problems before, anything that doesn't have an h got cancelled. I still have the limit. The h cancel out as well. And if we substitute in 0 for h, have just negative 7 over x squared. Of course, all of this we can confirm and verify using the power rule, but we have to show work using the definition. definition will be given. Just need to know how to apply that. So that is 23 to 25. We get back to this. Now power rule. The most fundamental skill set of calculus 1. So we need to know that. Right. So when we take derivative of the power rule, just go over what is the power rule. The rule of derivative, it says that derivative of x to the n power is n x to n minus 1. Derivative of x will be 1, and derivative of any constant is 0. Now we look at this, we see x negative 2, derivative of that will be negative 2, x negative 2 minus 1. So original power goes down, and then the original power minus 1. X cubed will be 3x squared, and then x will be just 1. Now, the coefficient will stay. We have plus 1 times plus 7 times, and here we should put the parentheses, and then 13 in front of it. So pretty much we take the derivative only of the power of x. Any constant will stay, and the plus and minus in the middle will stay, and you have, well, we have negative 26 x to the negative 3 plus 21x squared plus 1. So pretty straightforward. Here we haven't done the derivative yet, but what we need is have to rewrite x as the powers. So I will rewrite as follows. First, the square root of x, write that is 1/2. Now from that we can move all of that on the top. Every time we do that, change to negative exponent. I mean opposite of this before. So the power from the bottom to the top change to negative. So that is due to this formula. Right? We haven't done any derivative yet. Just rewrite the function. Now we take derivative. So I will do all of the power first. Negative 1/2 x to the negative 1/2 minus 1. X negative 1 is negative 1. X negative 1 minus 1. And then that negative 4. Bring down the power, original power minus 1. And this has a constant in front, minus 8 plus 7. So we have negative 2 x to negative 3/2 plus 8 x to negative 2 minus 24. 7 times 4, that is 28. X to negative 5. On the test we just leave the answer in this form. Once again, the derivative are those two lines, the function are those two lines. So do not mix them up. Usually I write something in the middle to distinguish the derivative and the function itself. Right. We can use the quotient rule on this, but what we do instead, I will not finish problem, but we can split the top. Now square root of x we can write as x to the 1/2. So due to this formula, so where we have the square root of x, by default we have the first power still the same, and square root means there is 2 there on the root, and the power on top, or the top is the power, the bottom is the index of radical. So that's why we have x to the 1/2, because that formula. The cube root will be 1/3. Right. Now this, we subtract those two things with the same basis. So we'll subtract the exponent because we're dividing them. This we do not subtract because different bases. We can just move that from the bottom to the top. And we simplify, we have x to the negative 1/2, I mean positive 1/2, plus 7x to the negative 1/2. The first one we have 1 minus 1/2 is 1/2. The second is negative 1/2, always there. Right. You can apply the power rule on this. So I'm not going to worry much about that. Now, our second derivative is just like derivative, but we have to do it twice. So derivative of this, we have x cubed will be just 2x. There's a 7 in front of it. Minus 8. By the way, I also have derivative of that. It's going to be 0 because any constant, derivative of a constant is 0. Yeah, we have that. So we write 21x squared minus 16x, and that's it. That 8 times 0 is 0. Now we do the same thing. For x squared, derivative is 2x. For 16x, derivative of x is just 1. Now we have, that is the second derivative. 21 stay in front, negative 16 stay there. That gives us 42x and minus 16. So pretty much we take derivative twice. Uh, 29 to 32. Right. Equation of tangent line. Look at this one. So equation of tangent line would be, it might be in different form. Y minus y1 equal the slope of the tangent line, x minus x1. We can write like that, or we can write y minus the values of the function at x1 equal to the tangent of x minus x1. Now we say the point is x equal to a at x equal to a, where a is 3. So this time, which means a1 is 3. I mean x1 is 3. Right. So we know something. Y minus f of 3. We don't know this. We do know that x is equal to 3. Right, so that much we know. Just need to find the values of the function at 3 and then the slope of the tangent line. Right. First, this is the function when x equal to 3 cubed. So that is 27 minus 27 plus 4, so it'll be just 4. Right. Now we need the derivative. So original function is that. When we check derivative, will be 3x squared minus 9. Actually, that's it. Now we will evaluate this at 3. That's 27 minus 9 is 18. So now we have everything. The 18 is the derivative, which is the slope. And then the values of the function will be equal to 4. So we have y minus 4 equal to 18x minus 54. And then with plus 4 on both sides, we have y equal to 18x minus 50. So that is equation of a tangent line. We need a difference in y, slope, different in x. Because if we need to derive that, we start with the slope equal to y2 minus y1 over x2 minus x1, which is rise over run. And then multiply x2, x1 on the other side. And we just drop the index 2, and we have y and x in the equation. So in the equation, most likely we will be given the point x1. So we know that. Just need to find the values of the function at x1 and the derivative at x1. We can use the calculator on this one. So try to find the derivative knowing the function. Right. Now, there's a lot of ways to do this. You can hit math, option number 8, I believe, and derivative, doing derivative numerically. So if I put that, now, if it is like this, it is easy to see derivative with respect to x. The function is x cubed. Let's do that for x cubed minus 9x plus 4, and the values of x equal to 3, and we have 18, close to 18. Not perfect. By the way, let me switch the calculator because it might look different on the other calculator. Right. Again, math number 8. Right, completely different. We have the function as x cubed minus 9x plus 4. X is the variable, and we evaluate at 3. the number is exactly like the one we have earlier. It just displays a little bit differently. So it is 18. So I think one of them is good enough. We just need to know the formula though. So derive from the slope to that form. So on the test you will be given either that or that. Right. So we finish all the topics on the test 1. I just want to finish by doing number 26. Right. So we have the graph of the function. Now try to graph the derivative. First, the slope of this one look like go up 1 to the right. So will be from negative 5 to, I put them 1, 2, 3, 4, 5. From negative 5 to negative 3. From negative 5 to negative 3, the slope is 1, because 1 up, 1 to the right. So the derivative equal to 1. And it's undefined at the corner. Next, we go from there to negative 1, to 0. Derivative will be 1 to the right and 1 down, so it's going to be negative 1. And then this go 2 up, 1 to the right, and that go up to 3. Yeah. Oh, sorry. About backward. So 2 up, 1 to the right, 2 up, 1 to the right. So this will be 2. Never mind. It's not this. Just a horizontal line. And from here, from 3 up to this point. And from here, from 3 to 5, it's horizontal line, so it's a constant. Right. So just find the slope for that segment, and then we draw the slope. Since all of this a linear function, so derivative is a constant, so that's why it's supposed to look like that. Right. Anyway, with that, we finish all the questions, all the topics. That will be on test 1. I hope this prepare you for the test. And once again, I'm sorry for the delay in the review.